All right, this is another example for the operations of functions dealing with the products and quotients. Previous video, I did example with products. Now I'm going to do one with the quotient. So here's the definition of a quotient, and I'm giving the two functions. I'm going to do the quotient of these two functions. I'll end up getting a new function, and then we're going to describe or find the domain. So f of x will be the square root of 3 over x, and g of x is the square root of x squared minus 1. All right, since they're both in radicals, I can write it as one radical, and that will be my new function. Okay, but now I want to describe the domain. So what I do is I go back and look at this one because the radicals will pull it apart. Now this one is a fun one. I think it is. It makes you think. All right. Here in the numerator, all right, you can have anything in the numerator, but we also have a radical. Inside the radical, we have a variable. So that means this right there automatically gives me a restriction, and the restriction is that what's inside 3x has to be greater than or equal to 0. In the previous problems, depending on what form this is it linear, quadratic, whatever, will determine the method I use to find the restriction. Well, this is linear, so I can just go ahead and solve as is. So there is the domain. Now we're just looking at it in graph-wise. All right, that would be the domain. That's to make just this part true. All right. Now we got this denominator, which also has a radical. All right. And inside the radical there is a variable. But since it's also in the denominator, that means there's two restrictions. The first restriction is that x squared minus 1 has to be greater than or equal to 0. But also, since it's in the denominator, x cannot equal, or not x, excuse me, the whole denominator, the whole thing, the square root of x squared minus 1 cannot equal to 0. So we got two restrictions going on just within this denominator. And that's not including what we just found in the numerator. All right? So you just take each part separately. So here we found part 1. We'll call this 1. We're going to call this 2. And we're going to call this part 3. Okay, this is part 1. Now, it's a quadratic. All right, let me switch to blue. All right. It's a quadratic, so that means I have to do the whole process what I did in the first video and what I've done in some previous videos as well. So I take x squared minus 1 set it equal to 0, solve. I make my number line. My little test point will be 0, so I plug 0 in, so 0 minus 1 is negative 1, and that is false. So that means I have the extremes. Okay. If it was true, it would be in between, but it's not, it's the extremes. All right. Now we have this third part. Okay. So now here we're solving, so we can just go ahead right from here. I'm just going to solve for x. So I square both sides. So I get x squared minus 1 cannot equal to 0. Add 1, so x squared cannot equal to 1. Take the square root, so x cannot equal to positive negative 1. All right, so in other words, these 2 points right here, all right, so let's combine these. Okay. So here's my number line. Here's negative 1 and here's 1. Well, for this one, I can include the points. Right? But this tells me I cannot include positive negative 1. So therefore, these become open circles now. So I took care of this one, and I took care of this one. What happens now? What I just showed you here satisfies these two parts. In other words, it just satisfies the denominator. It doesn't make the numerator true yet. All right? So now I'll take the domain that I found for the numerator, x is greater than or equal to 0. So here's 0. It's greater than or equal to, so it goes this way. Okay. Now, I need to find out where these two graphs, the blue and the black, what do they have? Where are they? What do they have in common? Where are they the same? Well, they're the same once it goes after 1. So everything after 1 will work. Okay? Because if I plug any value in here that's greater than 1, we'll make the denominator true. In other words, it will not be 0 in the denominator, and the value inside will be positive. And then when I plug the value up in here, my answer will still be positive. Okay, so this is my domain now. So now I can write it as x is greater than 1, or in interval notation, I can write it as, let's see, parenthesis 1, comma, infinity, parenthesis.